Okay. So tomorrow, remember, you have your quiz, but it's over this material, the homework that we just turned in. So coterminal, where you add and subtract 360, add and subtract 2 pi, the reference angles we just talked about. What's DMS again? Degrees, minutes, seconds. Okay, so I don't think that should be very difficult. This material that we're going to continue with today is not on your test, or excuse me, your quiz. It is on the test, I should say. And that's the second item I want to talk about. Coming up on Monday, the 8th, you have your first exam of the 6 weeks. I didn't put anything on there but these first 2 lessons on trig. So angles and their measures, and the right triangle trig lessons are what you're going to see. All right. Well, let's go ahead and take a look. Similarity. When we're talking about similarity, they have the same shape. Specifically, their angle measures are equal, and their sides are in proportion, or you could say proportional. Okay. There we go. All right, so I did pass these out yesterday. I have extra copies if you were absent or if you misplaced it. Okay, but we're going to go ahead and actually start talking about the trig functions themselves. There are 6 in all. 3 of them you're already familiar with because SOHCAHTOA, sine, cosine, and tangent. Now I want to talk about their reciprocals. Okay, let theta be an acute angle in the right triangle ABC is shown. Let's go ahead and find these. Now theta is the angle of interest. Okay, so one of the things you want to be very careful about what angle you're referring to because the sides associated with that could potentially change. And I'll show you what I mean in just a second. So let's say we have theta right here, okay, in the bottom left of the triangle. Well, what are the 3 sides? What do we call those? Hypotenuse, opposite, and adjacent, yes. So from theta's perspective, directly across from him, opposite BC would be the opposite side. Okay. The other leg that forms the right angle would be your adjacent. Okay. And then, of course, across from the 90-degree angle, that's always going to be your hypotenuse. Okay, so the first thing here is just to kind of refresh your memory on SOHCAHTOA and then introduce you to their reciprocals. Okay, all 3 trig functions have a reciprocal. So let's start with sine. If I wanted to take sine of theta, okay, does anybody remember what 2 sides will I use for sine? Opposite over hypotenuse. There we go. So opposite over hypotenuse. Okay. So what's cosine? Adjacent over hypotenuse. So we abbreviate that COS. Cosine of theta is equal to adjacent over the hypotenuse. Okay. Tangent. And I'm not talking about that guy at the beach. Tangent. Tangentleman. No? No? They did better in the other classes. Okay. So what's the ratio for tangent? Okay, so tangent of theta is the opposite over the adjacent. That is absolutely right. Now, each of these 3, okay, you remember SOHCAHTOA, okay, SOHCAHTOA, okay, for the letter each represented, either the trig function or the side length that it was going to use in its ratio. Now, each one of these has a reciprocal trig function that we want to take a look at. Sine, its reciprocal is cosecant. The reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. You're probably saying, wait a second, Mr. West, they have reciprocals? They do. Okay. So cosecant, that one didn't go over as well as I thought it would too, but okay. So if sine and cosecant are reciprocals, and I know sine is the opposite side over the hypotenuse, and cosecant would be the hypotenuse over the opposite side. There you go. And that's why I always encourage you when you're working these problems to go ahead and find sine, cosine, tangent, not only because you're more familiar with those, you've already seen them in geometry, but basically you would already have the answers for the others. You just have to take the reciprocal. So cosine is the reciprocal of secant, and we abbreviate that SEC. And what would his ratio be? Hypotenuse over the adjacent side. And finally, we have cotangent being the reciprocal of tangent. We abbreviate him COT, and he would be the adjacent over the opposite. There we go. The adjacent over the opposite. Okay. Questions? Now, one thing that we're really going to go ahead and start to look at, maybe today if we're able to get to it, if not definitely tomorrow, is what happens when we evaluate these. We're going to make a connection with these special right triangles. But whatever you're going to go ahead and put into a trig function, and it's going to be an angle measure, whether it's in degrees or radians, you're going to put in an angle measure, and what you're going to get in return, the output, is going to be the ratio of the sides of a right triangle. These guys in particular. And depending on the trig function, it'll be opposite, hypotenuse, or the adjacent. Now, I want to go ahead and show you something real fast. What I was talking about just a minute ago, let's say we're going to keep theta here, and we're going to go ahead and say that the other angle is called alpha, just so we can know and see the difference between them. Okay, well, let's say that we actually have some values. Let's say it's just a simple 3, 4, 5 right triangle. Okay, so 3, 4, 5, because it satisfies the Pythagorean theorem. 3 squared plus 4 squared would equal 5 squared, right? Okay. Well, what is sine of theta? Remember, it's opposite side over the hypotenuse. So what's opposite theta? Okay, 4 is directly opposite, right? Over the hypotenuse 5. Now, here's my question. Will sine of alpha be identical? Okay, no, because I'm talking about a different angle, right? So here, from alpha's point of view, 3 is his opposite, 4 is his adjacent. So it's very important you know what angle you're referring to. If you change angles, those sides are going to switch with it. So sine of alpha would be the opposite 3 over the hypotenuse 5. The one that does not change is the hypotenuse. Okay, but depending on the angle, the opposite and the adjacent can and will switch. Is everybody okay with that? Okay. Well, all right. Let's go ahead and start practicing some of these. Starting off with a 45, 45, 90 triangle. All right. Now, in terms of x, what are the side lengths? We know this is the only isosceles right triangle that we have. But what are the side lengths in terms of x? Does anybody remember? Angel? That's exactly right. He says x, and then x squared root of 2. So x and x represent the two legs because this is a isosceles right triangle. And then the hypotenuse is always x squared root of 2. So let me go ahead and put in 45 degrees, 45 degrees. Now, we're actually going to go ahead and plug in numerical values here. Let's say that x is just 1. Okay, just 1 unit long. So the legs are each 1. The hypotenuse would be 1 times the square root of 2, so this is just square root of 2. Okay. Now, given a triangle with these side lengths, I want to go ahead and figure out the value of these 6 trig functions. Okay. And does it matter which 45-degree angle I choose? No. Okay. Let's just say we're going to go ahead and base everything off this guy right here, just so we're all on the same page. Now, only a few people have actually taken me up on this today, just like we did a moment ago, where we labeled the sides as opposite, adjacent, and hypotenuse. If that helps you, maybe you want to go ahead and write that out. Does anybody want me to do that? Okay. So from this 45, what's opposite that is the 1. Okay. What's adjacent to it is this other length 1. So square root of 2 would be the hypotenuse. If that helps you to identify, the side lengths, absolutely, go ahead and do it. Okay. So let's take a look at the first one. And these are reminding us of what the ratios are. So the sine of 45 degrees, I want the opposite side over the hypotenuse. What would that be? Yeah, so the opposite 1 over the hypotenuse square root of 2. All I'm doing is plugging in the side lengths. Okay, that's evaluating the trig function for me. But there's one thing we want to be careful about. We don't like radicals typically in the denominator. Sometimes we're okay leaving them where they are, but here we want to get rid of them. We call that rationalizing. So does anybody know how I would get rid of that square root of 2? There you go. If it's a square root, you just multiply by itself. So I'm going to multiply by the square root of 2, but I've got to multiply the numerator by the same thing. Okay? Because what is square root of 2 divided by square root of 2? It's just 1, right? And if you multiply anything by 1, it stays the same. So we don't want to change his value. We want the same answer. We just want him to look differently. So let's see. 1 times square root of 2. And what's square root of 2 times square root of 2? The square root of 4, which is 2. See, that's the point. We want to multiply to get a perfect square root in the denominator so that we can simplify that. So the sine of 45 would be the square root of 2 over 2. There you go. Okay. Now, like I said, let's go sine, cosine, tangent, and then we'll worry about these new reciprocals. Okay. So let's say cosine of 45 degrees. So this time I want the adjacent, which is what? 1 over the hypotenuse, square root of 2. But isn't that exactly what we started with on sine of 45? Yeah. So, okay, we'll go ahead and rationalize that again. And I'm going to get the same answer. Okay. And that's perfectly fine. It'll happen for some of these. Okay. Now I want tangent of 45 degrees. So what's the opposite to 45? 1, the adjacent. 1, so 1 divided by 1 is just 1. Okay. Any questions on how I got sine, cosine, tangent? Okay. Now, here's what you can do. When you're looking for those reciprocals, you can just go straight to the diagram if you want. You can go ahead and set up the ratio of the sides, or you can take the information from the reciprocal and just flip it. Okay, and I'll go ahead and do a couple of these different ways just to show you that. Let's say cosecant. What was this ratio again? Hypotenuse over opposite, right? So if I go straight to the diagram, the hypotenuse is what? Square root of 2 over the opposite 1. So it's just square root of 2, right? So the diagram gave it to me straight. I don't have to do any extra work. But let's say you didn't think about going to the diagram. Let's choose our answer we got from sine of 45. Because sine and cosecant are reciprocals, right? So if I take square root of 2 over 2, and I just take the reciprocal, 2 over the square root of 2. Well, let's rationalize it, and what should be happening? What should I be getting? Should be getting square root of 2. Well, let's see if that's what happens. So this is going to be 2 square root of 2 when I multiply straight across. What's square root of 2 times square root of 2? Okay, 2, because the radicals cancel, right? And you'll notice here, the 2's cancel again. So what am I left with? Again, square root of 2. So however you decide you want to look at the problem, we should be able to get to the answer. See, we definitely got to the root of that problem. Yeah. You'll laugh later. Okay. So now secant of 45 degrees. But you'll notice sine of 45 and cosine of 45, what'd they give me? The same answer, right? So cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. So what should cosecant and secant of 45 be giving me? Same thing, square root of 2. We'd be taking the reciprocal of the same value. Okay. And then this last one, this is pretty straightforward. We know cotangent is the reciprocal of tangent now. So what's the reciprocal of 1? 1. 1 over 1 is still 1. There we go. So that was a 45, 45, 90. When we start looking at the unit circle next week, these triangles are going to be coming up a lot. Any questions? Okay. Well, now 30, 60, 90, but we're going to break this up. First, we're going to look at it with respect to 30, and then we'll look at it with 60. Okay, so I'm going to go ahead and put in 30 degrees, 60 degrees. So we want to focus everything on 30 this time. So a minute ago, Angel told me it was x square root of 2 for the side lengths of a 45, 45, 90. Does anybody remember the side lengths for a 30, 60, 90? It is x, 2x is the hypotenuse, and then we got to multiply by another radical. Square root of 3. There we go, okay. So the sides, the way they're marked here, x is always the shortest side, so it's always across from 30. X square root of 3 is always across from 60. That's the longer of the two legs. And then the hypotenuse is always 2x, double whatever the shortest side is. Okay, so here we're going to go ahead and do the exact same thing. Let's just say that x is 1. Okay, so the shorter side x is always across from 30, so that's 1. The hypotenuse is double that, so 2 times 1 is 2. So what should be across from 60? Just square root of 3. 1 times the square root of 3. Okay. Now, since we're going with 30, 1 is directly opposite him. 2 is the hypotenuse. So that means the square root of 3 has to be your what? Adjacent. Because for every one of these in this section, we're just looking at 30 degrees. Okay. All right, well, let's start with sine of 30 degrees. Genevieve, can you help me out with that one? I need the opposite side over the hypotenuse. 1 over 2. Opposite 1 over hypotenuse 2. No radical, we don't have to rationalize. We're good. Okay, 1/2. Alize, can you help me with cosine of 30 degrees? I want adjacent over hypotenuse. Okay, the adjacent square root of 3 over the hypotenuse 2. Perfect. Again, nothing we have to take care of, rationalize. Okay. Jayton, can you set up the tangent of 30 degrees for me? The opposite over the adjacent. Okay, the opposite 1 over the adjacent square root of 3. Now this one, I have to go ahead and rationalize. So what am I going to multiply by here? Okay, square root of 3 over square root of 3. Remember, this guy here, he's just a version of 1. Anything times 1 is itself. Okay, so can anybody tell me what my final answer here should be? Square root of 3 over 3. That's exactly right. Because the square root of 9 is 3. We simplified the denominator. Anybody having trouble seeing how I'm getting these? Anybody not sure where a value came from? Okay. All right, how about this? Jalen, can you help me out with cosecant of 30? Now, we can either take the ratio or just take the reciprocal of the sine function, whatever you like. There you go. The hypotenuse 2 over the opposite 1, that's just 2. Sine and cosecant are reciprocals. Okay? Just as cosine and secant are reciprocals. So here, secant of 30 degrees, hypotenuse of 2 over the adjacent square root of 3. All right, so another one we have to, what's that word again? Rationalize. So I'm going to multiply by square root of 3, square root of 3. So what am I going to get if I multiply this out? Yes, and that's all over 3. So 2 square roots of 3 over 3. There you go. That's all there is to it. This is the basis for everything we're going to be doing for quite some time. And our last one here, the cotangent of 30 degrees. Anybody tell me what the answer is? It is just the square root of 3. If you're going from the ratio, the adjacent is square root of 3 over the opposite 1, and just square root of 3. Does anybody want me to show you that if you do take the square root of 3 over 3, that reciprocal answer for tangent of 30, and flip it, we'll get the same thing? Nobody wants to see it? You do want to see it? Okay. So let's say you just took that and flipped it. So 3 over the square root of 3. Well, just like before, we need to multiply by that same radical. So this is going to give me 3 square root of 3 over what? 3. And just like in that previous set, remember when the 2's canceled, the 3's cancel here, and see I ended up with the same thing. Okay. All right, good. Good. Now that's a 30, 60, 90 where we focused on 30. Now let's do this same triangle, but for 60. So we have the same relationship. X is always the shorter leg. X square root of 3 is the longer leg. And then 2x is going to be the hypotenuse. So this time I'm going to go ahead and put 60 here. And I mean, really, it doesn't matter as long as you have your sides labeled correctly. Okay. So let's say x is 1. Okay, so this is going to be opposite 30, so this is 1. X square root of 3 is always opposite 60, so that's just square root of 3. And again, the hypotenuse would be 2, because 2 times 1. Okay, we're just saying x is 1 in this case. We're working with a very simple triangle. Okay, so where's the opposite this time if I'm going for 60? Okay, so this square root of 3 is directly opposite 60. Okay, so this would be hypotenuse, and then this one now is my adjacent. Okay. All right, so you have seen me run through a couple of these sets. Would anybody like to come on up here and show me sine of 60 degrees? Okay, and I'll tell you what we'll do. We'll go ahead and get a little train going. Okay, so Brandon, come on up, and I'll explain what that means in just a second.
I don't like it.
Okay, so Andrea is definitely on board. She loves the idea. Okay, so he says the opposite. So he says sine of 60 is going to be square root of 3 over 2. Is he right? That's perfect. Now, let's go ahead and do this. Brandon, who would you like to see come up and show me cosine of 60? That's what I'm referring to when I say the train. So we'll choose who wants to go next. Okay, Brandon chooses Brandon. Oh. So cosine of 60, this is the adjacent over the hypotenuse. Adjacent over hypotenuse, he says 1/2. Is he right? That's it. Brandon, who do you like? Angel. I like how now that we're doing this, a lot of people are not making eye contact with the person who is currently up at the board. All right, so he gets right to it. He says the opposite over the adjacent is square root of 3. That is absolutely right. Perfect. Angel, who's next? Leo. Now he has the first reciprocal, cosecant of 60. Hypotenuse over the opposite. There you go. And he just went straight to the final answer. 2 square root of 3 over 3. Okay, does anybody want me to elaborate on that? How he got that? Everybody's okay? All right, Leopold, who's up? Nathaniel. He has our second reciprocal, secant of 60 degrees, which will be the hypotenuse over the adjacent. 2, that's it. The reciprocal of 1/2 is 2. He's absolutely right. And who will be our last person today, Nathaniel? All right. Cotangent of 60 degrees. Adjacent over opposite. Okay, so 1 over the square root of 3. Okay, we're going to multiply both parts by that. Square root of 3. So he says square root of 3 over 3. What do you guys think? That's absolutely right. Perfect. Okay. Fantastic. Any questions? Okay. All right. One other detail. Okay. We're going to go ahead and not solve this problem. We'll go ahead and set it up so that way tomorrow when we come in, we can go ahead and finish up. So it says, let theta be an acute angle such that sine of theta equals 5/6. Okay, so I got a triangle over here. Now, it doesn't matter where I place theta, as long as the corresponding sides are correct. All right, would you like me to put theta below or above? Below. So let's put theta here. Now, what ratio is sine? It's what over what? It's opposite over hypotenuse. So if I go ahead and compare that to the fraction that I've got, those are giving me two side lengths of the triangle that I have. So I know that directly opposite theta, the height should be 5. The hypotenuse should be 6. Okay, there you go. See, now we got to go ahead and figure out what the other missing side is, because we don't have any other information to find that. What am I referring to here? Pythagorean theorem. The a squared plus b squared equals c squared. Okay, so definitely C is going to represent the hypotenuse, and it really doesn't matter which one you say is A and B, because those are just the two legs that form the right angle. So let's say A is 5, and we're looking for that missing side B. Okay, there you go. And if you feel comfortable enough, you could just go ahead and subtract it, write the equation out that way. So let's see, what is A squared? 25 plus B squared is equal to C squared. 36. Okay, and Nathan said we're going to subtract. Opposites cancel. B squared is equal to 11. How do I get B? Take the square root. Okay, so let me take these letters off right here. So I just found this missing side to be 11. Okay, and this is where we'll pick up tomorrow. We actually do not have a lot left to do. Anybody having a hard time with the right triangle trig? Okay, good.